This is section 7.3, multivariable linear systems. These are the objectives. Use back substitution to solve linear systems. Use Gaussian elimination to solve systems of linear equations. And use systems of linear equations to write partial fraction decompositions of rational expressions. This one, I'm warning you, is different, to a degree challenging. The first two bullets, they look very similar to what you have done in Algebra 2. This is the vocabulary key concepts. Here we go. Here's number one. It says use back substitution to solve the system of linear equations. So here's number one. So basically this is what we're going to do. We are going to plug in this z value back into this second equation, hence back substitution. So once we do that, this is what we get. 6y minus 5 times negative 2 equals negative 12. We go through some algebra here, and I end up with y is equal to negative 11 over 3. At this point, I know z, I know y. I'm going to go back to the first equation and substitute. So then I have 4x minus 3 times this y value minus 2 times the z value, which you see here. Do a little bit of algebra here, and I end up with x equals negative 8. Again, this is the process that we call back substitution. And the answer to this system is negative 8, negative 11 over 3, and negative 2. Let me go over something else. The process to get to a linear system can look like this is what we call Gaussian elimination. Here's number 2. It says solve the system of linear equations. The way that we're going to do this, we're going to apply the Gaussian elimination. So I'm going to make number 2 look like number 1, and then once it looks like number 1, I am going to apply back substitution. So the first thing that I'm going to do is I'm going to interchange the z's. I'm going to have, instead of having what you see here, x, y, z, now I'm going to have z, x, y, same thing, 2z minus x plus 3y, and then just shift those over so that x's line up and the y's line up. At this point, what I'm going to do is I'm going to eliminate this 2z in the same way that you did this in Algebra 2. First, I'm going to multiply the first equation by negative 2, both sides. This is what I get. At this point, I'm going to bring over the second equation, which you see there. And then, notice that when I add these two equations, I end up with negative 3x plus y equals 4. So then, this is what I'm going to work with now. Now, the second equation looks like this. Now, my goal, and again, remember I said that I was going to try to get rid of the 2z, which I did. Now my goal is to get rid of the 4x. So I'm going to work with the second equation and third equation. I'm going to multiply the second equation by 4, the third equation by 3, both sides. This is what I get. This is my second equation, third equation after the product. I add, and I get 7y equals 28. At this point, I get y is equal to 4. Then, this is what I have now. This is my system. And notice that it looks like number 1. And I was able to make it look like number 1, applying the Gaussian elimination process. Then, I'm going to use back substitution at this point, just like number 1. So once I put substitute y equals 4 into the second one, I get the following. Solve, I get x equals 0. Now that I know y and x, I'm going to go back and substitute it into the first equation. This is what I get when I substitute, and this is what I get for z. So my answer is 0, 4, negative 2. Let's go to the next slide. Same directions, same idea. I'm going to apply the Gaussian elimination and back substitution. Notice that this has more variables than number 1 and number 2, but not to worry, we're able to do this. It's going to take more steps. First thing that I'm going to do is I'm going to multiply the first equation by -1. I get the following, and then I'm going to add this new equation 1 to my second equation. Here's the second equation, and this is what I get. So then I'm going to be working with this system. This is my old second equation, this is my new second equation. So now my goal is to get rid of this 6x. So I'm going to work with the first equation. I'm going to multiply it times -3. I get the following. I bring over the third equation. I add. I get the following. So now I'm working with this system. Now my goal is to get rid of this 5y here. So I'm going to multiply the second equation by -1. I get the following. Bring over the last equation, the third equation, and I get the following, which gives me z equals 0. So then, let me erase the following. So then this is my new system. I have this. Once I have this, now I know that I can use back substitution. And again, I apply the Gaussian elimination. So I go back and plug in z equals 0 into the second. I get the following. Y is equal to 2/5. I have z, y, plug it into the first. I go through my math, and I get this as my answer. This is a different type of problem. This is write the partial fraction decomposition for the rational expression. You need to learn how to do this because, well, first of all, you're going to be quizzed and tested on. Secondly, you're going to see this in calculus, in your calculus sequence. So here we go. Basically, this is what you need to do. If you were to factor this denominator, you're able to get 2x plus 3 and 2x minus 3. This is where these two denominators come from. And then all you do is you write each factor as a denominator. You write a addition symbol between them. And then above it, you write a variable. In this case, I'm going to use capital A. And then on top of the second denominator, I'm going to use a different variable, capital B. Why you do this? Because it's the process that we use. And then at this point, I am going to multiply both sides of this equation by the least common denominator, which is 2x plus 3, 2x minus 3. And this is what I get. So let's move on. So what I'm going to do is I need to solve for a and b. And this is the process that I'm going to use. I'm going to let x equal 3/2. And once I do that, notice that I plug it in here. And I also plug it in here. But once I do that, I get the following. I still have 1. I still have the a. I still have the b. Instead of writing x, I write 3/2. 3/2. And notice what happens. This all becomes 0. This becomes 6. And at this point, my goal is to solve for a and b. This is going to allow me to solve for b. And b is equal to 1/6. Then at this point, I need to go back and find a. How am I going to find a? I am going to use a similar process as I did here. But now I'm going to let x equal -3/2. Why am I letting equal -3/2? Because once I substitute the x value, all of this is going to become 0, and b times 0 is 0. All of this becomes negative 6, and then at this point I'm able to solve for a, and I end up with negative 1/6. At this point, all I need to do is substitute a and b into my expression here, and I'm basically done. Same directions, so same process. I'm going to factor this denominator, and then I am going to have capital A and capital B right above. At this point, I multiply both sides of this rational expression by the least common denominator, which is x plus 3, x plus 1, and I get the following equation. My goal is to solve for a and b. I use a similar process to number 4, so I'm going to let x equal negative 1. Once I do that, all of this is going to go away, and it's going to allow me to find b. So once I substitute the x value, this becomes negative 1, negative 1, negative 1. I simplify this. This becomes 0, this becomes negative 3, this becomes 2, and at this point, you should see that you can solve for b, and you end up with negative 3/2. So now I need to find a. I'm going to use this expression again. I'm going to let x equal something else. Since I want to solve for a, I want to get rid of this, so I let x equal negative 3. And then at this point, I substitute x equals negative 3 into this expression, and I get the following. I simplify. This becomes 0, this becomes negative 2, this becomes negative 5. I'm able to solve for capital A, and I end up with 5/2. So then I go and substitute a and b, and this is your answer. Number 6. Same directions. Now you're looking at something a little bit more different. Same process. Now you're going to factor this, and you're going to notice that you're going to get x times x squared minus 9, but this becomes x times x plus 3, x minus 3. So then, this is what you have. Now, 3 denominators in 3 different variables, capital A, capital B, and capital C. Then at this point, you multiply by the LCD, and you end up with the following expression. So now, you are going to solve for A, B, and C. First thing that you're going to do, you're going to let x equal 0. Once you let x equal 0, you're going to notice that all of this is going to go away, and you're going to be able to solve for capital A. Once you plug in x equals 0 into your equation up here, you end up with the following. Verify the work, and you should agree with me. And then at this point, this goes away, so I'm able to solve for capital A, and you end up with A equals 1. So now let's substitute x equals 3. When you do that, you notice that you're going to be able to solve for capital B. The A, the C are going to go away. Simplify, you end up with the following. Solve for B, you get 2. Then, all you need to do is solve for C. So the way you do that, you're going to let x equal negative 3. Once you do that, this is going to go away, this is going to go away. And then at this point, you solve for capital C, and you end up with negative 2. So now that you know the A, the B, and the C, you go back. Excuse me. And you substitute up here, and you have the following expression as an answer, as the answer. And again, if you were to add these 3 rational expressions, you end up with the following. So same directions. This one is going to be similar process. The only difference, notice that this is all basically almost in factor form. The fact that you have x squared, this is how you're going to treat it. You're actually going to have three denominators, and these are your three denominators. Since you have to the second power, you need to first write it to the first power and also to the second power, and then have its own variable in the numerator. And then this one is just c over that denominator. So whenever you have some sort of base raised to second power, this is the process that you have to follow. If you don't, it will be wrong. Okay? So let's multiply by the LCD. This is what you get. You're going to let x equal to 0. Once you do that, this is going to go away. This is going to go away. So you're going to be able to solve for b. At this point, you clean it up. You end up with b is equal to -1. Next, I'm going to let x equal -1. And this is going to go away. This is going to go away. So you're going to be able to find capital C. You simplify. Once you substitute, you get this. You simplify. You end up with C is equal to 1. So now, if you were to plug in, the way that you're going to be able to solve for A is you're going to have to do the following. You're going to have to pick an x value that is not going to cancel. Basically, this expression that you see here. Okay, if you try x equals -1, this will become 0, and you're not going to be able to solve for A. If you try x equals 0, this is going to become 0, and the whole thing will become 0. So the trick is to pick an x value that is not going to make this go away. So and you pick something that is easy to work with, like x equals 1. If I plug x equals 1, notice that this doesn't go away. And this is what you have. So yeah, this all becomes 2, this becomes 2, this becomes just 1. And the left side, all it is, becomes just 5. But notice I used to have B and used to have C. But we know the value of C, which is up here. We know the value of B, which is over here. So now we substitute it, and we should be able to find capital A. This process is a little bit tricky. If you want me to clarify something in class, just let me know. But from here, this is just algebra, and you end up with A equals 3 once you solve for capital A. Then your final answer is the following. Let's go to the next slide. I'm basically just going to show you what you see there, and you should be able to follow what I'm showing you. Again, the fact that you have a binomial to the second power, first power, its own numerator, second power, it's different numerator or different variable. Multiply by the LCD, let x equal 0. When you let x equal 0, you're going to be able to solve for A. Now you let x equals 1. Once you do that, you're going to be able to solve for C. You let x equals 2, because that is going to help you solve for B. Very similar process as number 7. Substitute your A and your C, which you know from here. Clean it up, solve for B, which is equal to -1. This is your answer. Next slide. This is number 9. What I'm going to do with number 9, I'm basically going to show you the problem, and I'll clarify in class. So just copy this. So again, I'll clarify this in class, and this is the end of the video.